Initially, you uproot the seedling. Are you together? And note its weight. That is called, I'm going to call it W1. W1 is equal to weight of a seedling when not dry. With what?
Water.
Weight with the water. Is this clear? We have called it W1. Then after that, put the seedling in the oven. Am I clear? You put it in the oven for about 1 hour or 2 hours to dry out the water. Is that clear? Then after that, note its weight. W2. Now W2 means what? Weight of the seedling without water. Is this clear? Now, this W2 is what we call the dry mass. Am I clear?
Yes.
That is the dry mass of the seedling. So, if we subtract W2 from W1, you will get the amount of water in the plant. Is that clear? So for us now, we are interested in W2, weight of the seedling without water in it. That's what we call dry mass. Now, when you get a seed and they put it in the soil, are we together? What happens to the seed? Germination will take place. Let me serious. When you put the seed in the soil, you have planted it. What did we say is the first thing which happens to the seed? Yes. It first absorbs the water. Am I clear? It absorbs the water. Now, when the seed absorbs the water, the cotyledon swells. Are we together? The seed cord bursts. Isn't it? This means in the first 3-4 days, its weight increases. Weight increases. Weight means the weight of the seedling with water. Why does it increase? Because it has absorbed the water. So when it absorbs the water, its weight increases in the first 4 days. Are we together? But dry weight does not increase. Dry weight decreases. Why? Because in the first 3-4 days, the food which is in the endosperm and the cotyledon is being burnt in the process of respiration to provide energy for germination. So the food content in the cotyledon and the endosperm is reducing. Are you getting it? The food is reducing in the food store. Food is reducing. So if food is reducing, that means the dry weight will drop. Will reduce. So in our graph, as you see it there, from point A to point B, dry weight has decreased. Dry mass has decreased. If this was 15, this would be 10. So, from 15, it has decreased to 10. It's an assumption. So, the first few days, when you plant a seed, the dry weight decreases. But the wet weight will increase. So, if I was drawing a diagram of the weight, it would be like this. For it, it would be going upwards because the seed is absorbing water. Am I clear? Now, after 3 to 4 days, we have this distance from B to C. Are we together? From B to C. The dry weight is almost constant. Are you seeing it? It is almost constant between B and C. Why is dry weight constant here? Yes. Respiration. Of course, here food is oxidized, but the plant has started gaining new structures, such as roots. Remember, the food is being converted into roots and the shoots. Are we together? The food has been converted into roots and the shoot. So, between B and C, the dry weight begins to increase because new structures are being formed. Then between C and D, there is an increase, a rapid increase. Sometimes you call it exponential increase in dry weight. Now, what you should understand is that after around 7 days, after around 7 days, the seedling has started developing leaves. And the leaves are carrying out and the photosynthesis produces what? It produces food. And when that food is produced, it is converted into structures, such as roots and the shoot. So, the plant is increasing in growth, and its dry weight increases exponentially. So, between C and D, the plant has capacity to produce food and to produce new structures. Is this clear? Then, from here to here, it is almost constant. Why? At this time, the plant has become mature. It is no longer producing new structures. Are we together? It is not adding on new leaves, new flowers, new one. It has become mature. So, at that time, growth becomes stagnant. Then later, you will find another parent where this one drops. Okay? When this drops, that is at that time, we call it senescence. Senescence. The process of aging. Are we together? The process of aging. So during senescence, the growth reduces. So senescence begins to take place. Are we together? The food made is less than the body structure. Then you can put the plant That is. So this curve is called the sigmoid curve. That curve is called the sigmoid curve. This one, we shall bring it in biology. Section B, it will be number 31. Are we together? We can either bring it when it is drawn for you, or we give you figures. You plot a graph and draw it. Am I clear? You plot a graph and draw it. You remember? I told you the requirements of a graph. Graph, yes, mathematics, physics, history, geography. So a graph must have a title. Are we together? So in this paper, that number, they might give you a question and you're supposed to draw the graph. So when they tell you to draw the graph or to plot the graph, you must write the title first. The title carries 1 mark. Then only number 8 marks. So you take it seriously. 8 marks. The first mark is the title. The next one is to label the axes. Am I clear? Label the axes. Sometimes they give you plot a graph of A versus B, or plot a graph of A against B. So when they say A against B versus the A against Alex, A against B. Okay? You plot the graph like this. You put A on the vertical axis. All together, and B on the horizontal axis. Then you plot. Am I clear? So when they say A against, this one comes on the vertical axis, and that one goes on the horizontal axis. Is this clear? Yes. Next, I said axis must be labeled. Each point which you plot on the curve is a mark. Then after that, in the right hand corner this side, you write the scale used. And please, when you're writing the scale, you use the scale of geography. You know how to write the scale in geography? Yes. How do we write it? How do we write it? Someone give me the answer. I think we are in physics. 1 centimeter represent 50 cubic centimeters. So we write the whole word represent. Am I clear? Yes. And you must say that it is either vertical or horizontal. Vertical scale, horizontal scale. You state it. Am I clear? When you do that, 7 marks. That can be done even if you have never covered that topic. You can do that even if you have never covered that topic. So this business of leaving that number empty should stop. Plot. We have taught you how to plot. Go in the past papers and practice how to plot this graph. Then you bring a mark. I will guide you. Is this clear? Yes. Okay. Can we come back to the sigmoid curve? explanation I have been giving is there. Briefly, the graph slows down at first. Does that make sense? It slows down. Actually, you have it. It slows down at first, and then it increases rapidly. Members, when we say rapidly, when we use this word rapidly, when the increase is steep, okay, like this. That curve was like this. Then this is rapid. So in your description, whenever you see this, a steep gradient, you say rapid delay or exponentially. The graph increase exponentially or rapid delay. Is this clear? So it increases rapidly, reaching maximum. That marks the end of it.